Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the buckling analysis steps. Following the previous lessons, we are talking today about the buckling. We've already had an introduction about what is buckling and what is the purpose of making a buckling analysis. Today, to talk a little about the different steps. So buckling has, as the other calculations, also several stages or steps, what we may call it. The order of steps in terms of the user is to put together a study and to run calculations of this buckling analysis. So we have different steps. The first one, it is to create the study. So when we go to analysis, and I've opened one of the examples that the software brings installed. So the first thing is to create a study. So we can create a study. We can choose buckling. Okay, we accept this. So we've created the study. Then we need to apply the boundary conditions, and this is very similar to the statics analysis. So we use restraints, loads, I will say, okay, in this case here. So we need to apply the restraints, we need to apply loads, and this will lead to what we call apply boundary conditions, which is the second step. I want to open this model again, not saving this model again. In this particular case, we have already restraints here and loads on the top. So we apply these conditions. Then when we have all of these things defined, and we have a lot of examples for this case, we simply go and run the calculations. We have a couple of things to notice about these solving methods, thermal effects if applied or not, and choosing the results that we want to check. So we go for this solution, and in this particular case, okay, we run the calculations and then we get results. And getting results, we go to this tree, we get these results, we have only one thing, and we can check the results that we obtain with the conditions that were defined. There are basically two types of conditions. One, it is the load factor. This is a coefficient, and basically this load factor means that we can find equilibrium state mode in terms of our model. Besides, we can find also displacements that correspond to the given critical load. So these are the two things we can find in terms of the results. I can, in this particular case, play this animation so that we can see what we have. And when we finish the calculation with success, we need to check the results that we obtain. So we need to make evaluation of the results. And we can evaluate the results in terms of three topics. One, it is what we call the solution evaluation, where we check the load factor. And this load factor must be positive. If this factor it is negative, this means that the loads that are applied to the elements or the structure that we are studying do not produce buckling. So you see that in our particular example, we have a positive value, and that comes from 0 to a positive value. Then we can, if we have buckling, we can evaluate the load factor itself. And if it is positive and less than 1, that means that the buckling will occur under the loads that we are applying. And in this case, the structure will need enhancements. If it is positive and it is greater than 1, then the system has no buckling and under the conditions that are specified. We have another thing called the buckling mode analysis. In this particular case, when I chose the conditions to solve, I did not choose any only one buckling mode. I could choose others, so but I leave the parameter in 1. But these modes, they defined the states of steadiness, or what we call with the smallest critical loading that we get in this structure. So this value is also used for optimizing the product design with the idea to increase the resistance to buckling. So these are the things that we can check with these steps of the buckling analysis. And to finish, just to notice that we have here mode 1 because we have only one mode to check in the example that was given here.